I'm Jason Hall. I work for Bluehost. Hey, we're silver sponsors, and we're hiring. If anybody wants to, we've got offices all over the world, so we're hiring in Perl positions pretty much everywhere. So if you're interested, you can contact us. We have jobs forums on our page. My personal email's there if anybody ever has questions or anything. So let's get moving. What is modern Perl? How many people here have heard that term before? Good, a few of you guys. How many are completely unfamiliar with modern Perl as a term? Good, okay. So modern Perl obviously helps you understand that there's an archaic Perl, right? This is the old Perl that some people complain about from the 90s. You know, it's the old CGI world where, you know, the coding of the 90s, early 2000s. Well, years back, Chromatic published a book called Modern Perl, and several other people have kind of come into the world, started talking about what they had of an opinion of what modern Perl is. And really it's a renaissance in the Perl world where a lot of people started going back to the roots of Perl, of cherry picking some of the best features of other languages, some of the things that they really liked, and modernizing the language. And not just the language, but the toolkit itself. And a lot of modern Perl, if you read about, will actually focus on the language, but I'm going to talk about the tools themselves. Part of that has been, for the last few years, a lot of people have worked really hard to create a very frequent release cycle of Perl. It's nice, it's stable, it's documented, and you can follow along, and you know that, you know, each year you're going to have these certain releases, and every 2 years, you know, a full release that you can just follow. And you need to update, you need to work along with it. And as a coder, sometimes you need to be able to test between different versions that exist, especially as things are becoming more frequent. If you have a live system, a large system that exists out there, you need to be able to say, great, there's a new version of Perl coming out, it's got some features I want, but I need to make sure my existing code base works against it. How do you do that? Okay, well, of course, the Perl world has brought in a lot of great tools for that. Perl Brew and PLENV are two great tools that you might already be using on a laptop. What they'll do is they'll allow you to manage several different types of Perl and be able to, you know, manage, you know, which compiler options you might have for them. You have a 520, a 524, a 522.2, and you want to run your code against all of them. Great, it lets you do that. It's very, very useful, great tools. You also have things like Carton that'll allow you to bundle up your dependency chain and say, great, I want to go run my application on a new box. It's going to automatically be able to pull in all its CPAN modules that you naturally use and bring them in and make them run in your system. Very useful tool. There's also software collections. If you're not familiar with that, that's a tool in the Red Hat CentOS world that allows you to build your own custom stack and side install it still using RPM without interfering with the system Perl. Now, I know at work that's a big deal because you have a bunch of system administrators that won't let you install anything without RPM because they need to manage it. Their necks are on the line. But you want to have something a little more modern than the, you know, totally decrepit Perl 5.8 that's on your CentOS 5 or Perl 5.10 that's on your CentOS 6. So software collections allows you to do that. So these are all certain tools that exist out there. Hopefully you're using, and they've given you useful things in your life up till now. But what's coming next is Docker, right? Docker is an important tool, and that's kind of why, you know, people are probably here. We're going to talk a little bit about that. What is Docker is something we'll talk about very quickly and then move on from there to why it's useful for a Perl programmer, both on your local system and beyond. So how many people here are already familiar with Docker by a show of hands? Okay. How many people are using it in their day-to-day development? See, not so much. Okay. I hope that from this, you know, basic intro, you guys will see that it is a useful tool, along with some of those things that we already listed. So for those who don't know, Docker is a containerization system. What it is not is a virtual machine. Okay. This is an important distinction. The concept about this is let's take the idea of a virtual machine and slice off all the extra stuff that you don't really need. Now, managing virtual machines is a very necessary thing. Virtual machines are very useful for a lot of stuff. There's a talk about using Vagrant to do that in this room later on this week. I just forgot what time it is, but please look that up. Highly recommended, and it's useful for something to have alongside Docker in your toolkits. The reason for that is, like I mentioned, Docker as a container is just the pieces of a virtual machine that you need. Everything else is cut out, put to the side, and you have a very lightweight piece that you can carry around quickly and replicate to have your system. Docker, because of that, also encourages you to have these images that are stateless, right? You can bring up something that runs your system and can immediately be destroyed, and that's okay. Your application's fine without that. So oftentimes in a production environment, you might have Docker running your front-end application servers. Your API, your microservices is a really great use for it. But something where you need heavy performance or a large stateful system, well, you're probably going to have more like a bare metal or a VM running your database server, right? And so you can get them to work together and be a very useful system. Now, when it comes down to your local system, though, it becomes more useful where we're going to explain here how you can use Docker to replicate a large-scale system, but on a very small scale in your laptop and be able to do a full-size development stack. And it's very helpful. So part of the basis of that is a Docker image. So there are a lot of pre-built images that represent things you commonly use in your environment. And so the most common one that we're going to talk about today is Perl, right? You want a Perl. If you were trying to be modern Perl and you want to do this on your laptop, you're using either Perl Brew or PLENV, and you're compiling out a whole bunch of these different Perls and being able to say, you know, Perl exec against one of these different systems, test your code against 520, 524. With Docker, you can actually just pull down those images. You don't have to go compile them for yourself. Someone else already did it. So I've got a little example here. I'll go through picking out and running a quick REPL environment on different Perls. As you can see right here, I start out and I say, hey, I want the Perl latest. I do a Perl DE1 in it. Great, I get an environment with the latest Perl. Try it again. I want to try exactly Perl 522. It'll grab that version. I can do the exact same thing that easy. And let's say I want to be really modern Perl. I want to run Perl 6. It's that easy. I didn't have to go through and recompile every single one of those things on my own. I didn't have to have that full environment and know if I had the latest version, but I could actually say which specific version, grab it from the cloud, and run my REPL against that. That's extremely easy and extremely useful because it's just this tiny piece that you can copy down that quickly. And once you've pulled it down, you'll keep using that cached version all you want, and it was that fast. But of course, most of the time, you want to run more than just a simple REPL environment. You say, I want to take a current Perl and run the code that I have on my system that I'm actually developing. And even more importantly is I'm going to want to add a dependency toolchain because who programs in Perl without CPAN, right? You need to be able to access CPAN. Well, guess what? These Perl images that you get from Docker, all they come with is core Perl, right? Because they're starting out clean as a base system. So you need to get something in there. You can do that from the command line. You can start out and you can build things up. And that's one example. You'll see some people, they'll grab this Perl, they'll go into it with an interactive terminal, start compiling, adding things in, and then they'll save that out and say, okay, I just ran through, I built up my image, I'm good. Oftentimes this is also what you might do in a development environment. Grab a clean base Perl, run through a script that just says, hey, start loading in the modules that I know that I need and see if my stuff runs, find if there's any errors. Great, I can start over from a clean room again extremely easily. I don't have to go and RM out a whole bunch of CPAN modules and see if I got it right so I can try again from scratch. No, I can prove from a baseline very easily. But Docker also has a complete toolkit to make that even easier when you pick points that you want. It actually is built around Git concept, and so you can build up a baseline of what you want, install in the modules that you're going to use, and then have that image saved out as your own thing that you can just reuse at any time. Pick that checkpoint, start from there. Makes life really easy. You do that using the Docker build, tag, and push tools. They're all command line. They're extremely easy. And you can use the public registry servers. They're great for open source. Lots of people have published lots of code out there. But you can also set up your own registry if you're doing internal projects. There's also tools, depending on your hosting provider, such as like AWS. They have their own registry systems where you can push into your own tool chain and take advantage of that if that's what you want to do.
So here's an example of saying I want to take one of these images and run some of my own code. So very quickly, I just run a Docker run. The -it means I want to start off with an interactive terminal. Give that. The --rm means clean up after myself. Otherwise, it will close, stop the running process, but leave that container that you could debug or do something else with. So sometimes that's handy, but I want to clean up here. The next thing is the -v is I'm actually loading a volume. I'm giving it a directory on my box and publishing that into my Docker container. So my source Mojo is going to be mounted as /app inside of that container. Makes life really easy. I then tell it which image I want to use. In this case, I'm using one of mine called Perl extended that I did as a demo. And I'm just giving it the command morbo hello.pl. So it's a quick Mojo script. Immediately just comes down and starts up the server on port 3000, just like default. It's that easy. It's now running my code. I can test things, run things against it. But that command could be anything else, right? It could be carton my script name, which will auto-run some of my downloads, get my stuff set up, and then run my script, right? So I could start off from that base Perl, throw in what I wanted, and then go. But in this case, I'm using an image that I had created. It already has my dependencies, so I can just tell it, hey, start. I'm good to go. So other examples, your command might be diesel author deps and pipe that into cpanm. Let's get things set up. So that's nice, but how many times do you want to type all that out to run your script? Obviously not very much, and that's where the Dockerfile comes in handy. Now, Dockerfiles are not unique to Perl Docker. This is the same concept you'll use using Docker for anything. They have a series of commands of, it's a DSL that you describe out what you want your image to be. And this, don't take too many notes. This is a low effectiveness example to show where a lot of people start. You can tell here the first command is from. So I say, what image am I basing off of? In this case, I would say, hey, I want the latest public Perl. All right. I set in a few environment variables into that system, and then I do a bunch of runs, which is, hey, go into that environment and do this thing. Now, one of the things that's important here is each time you say run, each one of these lines, it's actually a checkpoint in the build process, and it will save a layer. Okay, so each layer is nice because if you make a change later on, the next build can go through all the cache, make sure they're the same, and only pick up where you left off. So your rebuilds can get a lot faster. But when you have a whole bunch of lines, a whole bunch of layers, well, that's extra space that does get added. So you've got to weigh out how many cache checkpoints do I need versus, how much do I actually need to get things going quickly. Some of the other options in there, I have a workdir, so I defined it as, hey, my /app, that's where when you log in, your CWD is going to be, you're going to show up in /app, so you're already there. Don't have to CD anywhere. Expose means that's the port I just want to default publicly put out. Now, each of these commands, there's some great documentation on their site. There's a lot of different options, so you can remap ports if you want. You can put them on specific ETH devices, right? A lot of options you can do there. And then there's a default command. In this case, hey, I started a Perl REPL using the Mojo libraries in there as well. Great, simple command. This is a way that you can build out an application, build out a tool of, hey, I want you to have this ready to go so I can start it up at no startup cost. I don't have to rebuild, I don't have to do anything. It'll start in less than a second, right? But there's things you can do to make that faster and to make it better in your workflow. Now, you don't have to pay attention to details in this screen, that's why it's so small. What I just wanted to get the idea here is that you can actually chain things together. So this is an example in my VI. I've got a split window where I have two different Docker files. The top one, I decided that, hey, I was going to optimize out my, my base layer a little bit. So what I did is instead of starting from the standard Perl, I wanted to see if I could make that a little more efficient. And why does that matter? I mean, I already mentioned that Docker is quick, it's small. Well, the fact is the default Perl image in the Docker registries last month was around 750 megs. Now, if you take a VM and you strip out everything you don't need, does Perl really take 750 megs? No, not even remotely. So what I did is, if you notice the top, I have from Alpine. If you haven't heard of it, Alpine Linux is a very minimalist distro. It's very handy. The Docker team's really coalescing around it, getting a lot of traction. And so this was my test where I was starting to play around with how small could I make Perl. And so I have this run command where you see a bunch of ands. That's where I chain a whole bunch of commands into one block. So I have a single cache layer that does a whole bunch of things that I wanted, nice and small. I can always pick up from there. Now that run command could have been my Perl brew or PLENV and just dynamically loaded in, hey, which version do I want you to be in? But in this case, I was playing around with really making it small. So that created a Perl version that I wanted to use, and this one comes out at 75 megs. Now, how quickly could you start up an app on a remote server if it only needed to download 75 megs to run? That's a lot faster than 750. So this is really great if you're running in something like AWS and you wanted to have, stack in a whole bunch of stuff into a really low cost footprint. Alpine lets you do that really well. And then from there, the bottom one is a Dockerfile where I just said, great, base off of that one that I just created and load in some extended modules to get ready for myself. The Mojo and Diskzilla and, kitchen sink things that I might want for a more enhanced application. And what's great is that one's only about 79 megs still. So it's very small. These two work together though and give me a full Perl in such a small footprint by just taking advantage of reading the documentation and getting a few things ready for myself so I can quickly deploy applications out wherever I want. Then to get them to play nicely together, Docker Compose is your friend. So Docker Compose is a way to define out, hey, a set of these Dockers, these images, and let them know about each other. Once again, great documentation on the websites. I'm using some very simplistic features here where I just describe, hey, I've got a box named API that uses that image I just created. Here's the command it'll run, overriding any default commands that were in the system. Hey, I want you to, all your runtime configuration, you set up in there, and I'm linking it to some other stuff. So I wanted to go all hipster for this example here, so I've got Mongo and Redis, because you need both of them for little apps for some reason. Yeah, very, very simplistic, who cares, but I just wanted to get that point, that you can create a whole system design, make sure things know about each other, have their dependencies, and you can start it up very, very easily. And this can also define a full build process instead of images. Those are all features there that you might want to do on your laptop. Great, I sketch out, because nobody builds a single monolithic app anymore. You can define all your little microservices, the bus that they sit around, the database they're working with, and then just start it up with a single command. And that helps you in automating your system, both in the alpha and then making it be something you can replicate in a staging, a test environment, anything else. And also, if you want, you can then use that to deploy, or you can quickly port that into other systems such as AWS or use Kubernetes to design a very large scalable system and get it to go where you want. Docker makes that very simple so that you can have exactly what you're doing on your laptop with an entire system and just say, go play it over there now very quickly. And you know what you're getting. I mean, if you're into the DevOps type world, this makes life really nice. So where do we go from there? Well, live demo, of course. So here's, like I was describing, a very basic system. I just created a tiny code that is a simple API in Mojolicious, talks to a Redis that can do a pub sub type method with a worker and then a Mongo, just to exist, just so we can describe these systems. And I will do that with here. Get my mouse across. So what I will do is I have that Docker Compose file that I showed you guys, and I'm just going to say up, and it's running. So that entire system, and by default, Docker Compose up puts all your logging straight to this interface. You can background it, whatever you want. In this case, I want it here so that I can see the logs. And you can see the last time each box, each Docker is putting its own logs out. The cust event one and API one are their own boxes there. So let's clear this out. Oh, come on. Oh. Anyways, so that's on port 3000, I'm just going to hit this little port, and it's going to quickly dump some, log that it got the request, dump something into pub sub, which then the cust event box is going to pick up and take action on. Very simple. And it just, gave me my warrants as all of them ran. So I was able to stand up, as you saw very quickly, an entire multi-box system on my laptop using very, very little memory, and it runs. The boxes talk to each other, they have their own ports, they have the security, everything's correct. Cleanup, of course, is very easy. Just press that, it'll shut down the boxes gracefully. All their state is cleaned out the way that I wanted. And if I want to, I can then get rid of my containers very easily. Done. So, get back over here. That is the example. Any questions?
Can you have any commentary on the Docker security or lack of security model?
Yeah, so I actually do a lot of PCI work. I'm an ISA. Security is very important. And yeah, Docker is a very newer tool. The lack of security model has come up, especially, was it 2 weeks ago, there was an exploit that's been getting a lot of discussion about attempting to post in. It's an active thing that's being worked on in the community. There are, especially when you talk about using Docker in a live environment, I think is a very separate discussion from using it in your development environment. And that's what's really nice here, is that I can dev that out on my own resources, and I don't have to use those Docker files anymore in live, is because I just use them to test my code. If you want to use Docker in live, there is it's a whole separate discussion, but worth having, and it's something that's actively being worked on, but I would pay attention to that before trusting it fully, especially in a high security environment. So.
I just wanted to comment that the new beta, Docker for Mac, the native.
That's the one I'm running right here.
Yeah, that was huge for me.
Yeah.
It's so much more approachable and easier on resources.
Yeah, so.
Before, and now I'm starting.
Yeah, Docker is built completely around using newer features such as C groups in the Linux kernel. So when you're using it on Linux, it's all native stuff. When you're using it on Mac or when you're using it on Windows, you used to have to do it through a VM system. VirtualBox is the most common one. They have introduced the Docker for Mac and Docker for Windows betas. The Mac one's way ahead. That's what I'm using right now. You still have to get signed into the beta, but it's based around Alpine as well for the base system. It's a lot lighter, a lot easier, very fast. But don't let that stop you from getting your feet wet and trying with it. It's still easy using the VirtualBox method. It's just some extra steps. But yeah, the beta is becoming very stable right now and is very nice. So, anything else? Thank you.